Kia ora, and here are two exam problems looking at parametric equations. So if you're watching this and you're in 13 MCA 2022, we have done the very first part of parametric differentiation. We've learned how to find the first and the second derivative. What we're doing in these questions is starting to build up to applying those skills. Okay, so these are both taken from Pure 2 exams, which we don't sit, but which have lots of lovely old exam problems. In this first one, we've got two parametric equations. X is equal to the natural log of t plus 1, and then y squared is equal to t squared times the natural log of t. Now, we're not told anything about values of t for which those values are defined, but whenever you're working with a natural log function, it is well worth looking at what the argument is, right? Because we know that ln of x looks like this, right? Bad drawing, first bad drawing of many. And for this, we need to have x has got to be greater than 0. So in here, t has got to be greater than -1. And in here, t has got to be strictly positive. And often when you're doing problems about stationary points, you'll end up getting a value that is not valid because of the restriction all the way back in the x and y part. And you're going to see that in both of these questions that I'm going to do now. Okay, so that's just a good thing to start thinking about whenever you see a log question. Right, first up, for 5 very generous marks, we have to find an expression for dy by dx in terms of t. So I'll just move out here. X is equal to the natural log of t plus 1. This should be feeling pretty easy now. So dx by dt is equal to 1 over t plus 1. And y is equal to t squared times the natural log of t. Now this is a bit of product rule practice. Dy by dt is going to be t squared times 1 over t, so the first function times the derivative of the second, plus the second function times the derivative of the first function. Let's clean that up first. So we get t plus 2t ln of t. Now dy by dx is equal to this by the chain rule, and we can simplify that down to y dash over x dash. So y dash is this thing here, and this is x dash. What does that give us? Well, we've got in the numerator, am I going to clean it up? Yes, I am. I'm going to factorize out that t, and I've got this t into 1 plus 2 ln of t, and I'm dividing by x dash, so I'm dividing by 1 over t plus 1. That gives me a final expression of dy by dx is equal to t plus 1 times t times 1 plus 2 times the natural log of t. Okay, so there's our first 5 marks. Okay, next thing, find the exact value of t at the stationary point. Right, we know that a stationary point happens when the gradient is equal to 0. And that's the same whether we're working with parametric or whatever. So all we have to do now is to solve dy by dx is equal to 0. So dy by dx is equal to t plus 1 times t plus 1 plus 2 ln of t. This looks like it's going to give me 3 values. So either t equals 0 or t equals -1 or 1 plus 2 ln t equals 0. But this is where the thing I was talking about at the start comes in. If you go back to your x and y's, neither 0 nor -1 is a valid solution, right? Because we can't have the natural log of 0 in there, and we can't have the natural log of -1 in there. So all we have to say here is not valid for x and y, and then that leaves us with this one value here. And we have to get, I think we had to get an exact value for this. So 2 ln t is equal to -1, ln t is equal to -1/2, and exponentiating both sides, which is how we undo the natural log, we get t is equal to e to the -1/2. Right? So t is equal to e to the -1/2 is what's going to give me my stationary point. So it's that parameter value where I'll have the stationary point. Now that's all we've been asked to do here, find the exact value of t at the stationary point. What we could have been asked to do is to find the exact value of the stationary point, and then we'd take t equals e to the -1/2, and we'd take that t value and we'd shove it in here and here, and we get some values for x and y. I'm not going to do that here because the next question is also going to take a wee bit of time. The last thing we have to do is to find the gradient of the curve at the point where it crosses the x-axis. Okay, this is my curve. Where will it cross the x-axis? What does that mean? Well, that just means y must be equal to 0. So y equals 0 means t squared times the natural log of t equals 0. So either this is 0 or the natural log of t is equal to 0. But we know, again, that t can't equal 0 because that wouldn't be valid in here. Where is the natural log of t equal to 0? Well, that happens when t is equal to 1, right? So think back to last year when you first saw log graphs. All log graphs are going to go through this point here. So this is x, this is 1, and the log of 1 is 0. Right? And that's because of the property that 2 to the power of 0 is 1, right? 5 to the power of 0 is 1. Anything to the power of 0 is 1. And in this case, e to the power of 0 is 1. I'm going to stop going on now. Right, so that's t equals 1 is the value that we want for the point where it crosses the x-axis. Right, so it's going to cross the x-axis where t is equal to 1. Now what I have to do is take that t value and use my expression for the gradient. Let me just find some more space. Right, so t equals 1 gives us the x-axis crossing. And we know that dy by dx is equal to this. So we're going to substitute this into here. It gives me 1 times 2 times 1 plus 2 ln of 1, which is 1 times 2 times this thing here is 0. So my final answer for the gradient is just that m, or the gradient, at that point is equal to 2. Okay, 7.5 minutes. Just got time to do the second question. Let's just scroll up and see what we've got. Right, this one is kind of similar. It's got natural logs and it's got exponentials. So I've partly picked these two questions to give you heaps of practice with that because we've just been doing lots of work with trig. We need to do these ones as well. We're asked to find the equation of the tangent to the curve at the origin. Now, at the origin, the point is 0, 0. The gradient for a parametric thing is going to be in terms of t. So the first thing we have to do is to say, well, if we're at the origin, what does that mean about the value of t? So y is equal to 0, which is equal to 3t times e to the power of 2t. That means that t must equal 0 because this is never going to equal to 0. And 3t will be 0 when t is 0. All I have to do now is to find dy by dx. So quickly going through this, dy by dt is going to be 3t times 2e to the 2t plus 3 times e to the 2t. What does that give me? Well, we can clean that up a wee bit. We get 6t e to the 2t plus 3e to the 2t. That's the first bit done. Now we have to do dx by dt. Which is slightly easier. So what was x? X is t plus the natural log of t plus 1. So dx by dt is 1 plus 1 over t plus 1. Cleaning that up gives me t plus 1 plus 1, which is t plus 2 over t plus 1. And dy by dx is y dash over x dash. So that's my next step. Really should just have started a new page. Never mind. Okay, so dy by dx is y dash over x dash, which gives us 6t, this thing here. I don't know if anyone's still watching. Hopefully someone out there is still watching, right? Is that, and now we're dividing by t plus 2 over t plus 1. Cleaning that up gives me t plus 1, and I'm also going to do some factorising here. T plus 1 times 3e to the 2t, I'm taking out my highest common factor here, times 2t plus 1. So that's my expression for dy by dx. Right, now we need that because the question was asking me to find the equation of the tangent to the curve at the origin. So all I've got to do is to find dy by dx when t is equal to 0. So we're going to substitute, you can do this while I'm cleaning up my screen, substitute in t equals 0, and that's going to give me m, my gradient. So t plus 1, so 1 times 3e to the 0 times 2 times 0 plus 1 over 0 plus 2. Now it's worth doing that quite slowly. It's very easy to muck up questions like this. So we've got 3 times 1 times 1 divided by 2, which is 3 over 2. And we know that it goes through the origin, so that means that there's no y-intercept. So the equation of the tangent is simply y is equal to 3 over 2x. So we're just about there, so hang in there. If you're finding this, this is 9 marks, so this is quite a bit, you might want to pause that and then just come back to it and maybe try and do the question yourself in a couple of hours or the next day. The last bit that I'm going to do is to find the equation of the stationary point. And we have to give each coordinate to 2 decimal places. We have to think about what does a stationary point mean. Well, that means dy by dx is equal to 0. So dy by dx is 3e to the 2t times 2t plus 1 times t plus 1 over t plus 2, and that needs to equal 0. So what are my possible values here going to be? Well, look at the denominator doesn't matter. We just can't have it equaling 0. So we either have 3e to the 2t equals 0, or 2t plus 1 equals 0, or t plus 1 equals 0. So t equals -1. That's not valid. Right? And it's not valid because x can't have t of -1. So x is not defined. Right, what's next? Well, this one here, there's no solution. So the only one we've got is this one here, and t is equal to -1/2. Now let's check if that works with my original equations. Well, yes, it does, right? Because there's no problem here, and then in here, I've got -1/2, but I'm adding 1 to it, so it's a positive number. Okay, what's the next thing we've got to do? Oh, we're just about there. All we have to do now is find the stationary point. So we've found the value of t. T is equal to -1/2. So now we need to go and substitute that in and get x and y. So x is equal to -1/2 plus the natural log of t, which gives me -1/2 plus the natural log of 1/2, and that equals -1.19 to 2 dp. What about y? Well, y is going to be equal to 3t times e to the power of something, e to the power of 2t. So it's e to the power of -1, and that gives me -0.55 to 2 dp. Okay, so there you go, just about on 15 minutes. If you've got questions about these or have got other questions you'd like me to video, it is quite a hard part of the course, I think, because there are a lot of steps involved. So let me know if you do have questions.